Hello everybody and welcome to our new tutorial today. We're still in the series of building static model by Petrel from A to Z, and in last tutorial we already knew how to build a 3D grid model without any properties using digitized surface maps as well as bounding folds. Today we're gonna show you how to fill these constructed grids by properties, petrophysical properties. By the end of this tutorial you will be able to construct or populate the properties with this sort of properties like permeability, as well as porosity and water saturation and so on. Let's start from the end of the last tutorial. Let's make a copy from this already created model, Ctrl C and Ctrl V again, and let's please name it by Vanarco, then click enter. As we discussed, we have a skeleton of three layers, as you see here. Now go for structural imaging, structural modeling, and point to horizon, top for top horizon, Wash G top and point here, and Wash G bottom, point here again. For this input, Wash G bottom here, okay. For Wash G top here, then apply, and okay. Now you see these two icons are activated now and ready for use. Let's define the zones. How many zones in your model do you want to create? In this example we use 5 zones, vertical zones, name it 5. You can use number of zones or input type ISO, core, constant or comfortable. We can leave this one as empty for a while, then apply. Okay, you see here 5 zones already created, but you have to define each zone. What is the thickness for each zone? For our simplicity and in this tutorial only, we can make the percentage for each zone any numbers, but be sure the rest at the end of this listing you have to have 100% as a total input. For a while we can use in the top horizon, just example, and you can change number later on, no problem, and 30% of the total thickness, and 60, then 20 for example. Okay, this 1% for each zone from the total zone thickness. When you apply in this case, you come up with this error message: volume correction is on, but it's turned off for off on all zones. Now you have to turn the volume correction none, then apply, and okay. Now you have 5 zones already generated. Let's see what happened in each zone. Yes, these 5 zones already generated in between the top and bottom of this model. Now we're gonna fill all of these zones, 5 zones, with petrophysical properties. let's go for property modeling and click geometrical approach. We have three different approaches, but we use for now very simplest way, which is geometrical approach. Later on we will discuss how to generate a facies modeling as well as petrophysical modeling. For this purpose of tutorial, we are going to use geometrical approach and choose what property you need to model. Let's go for porosity, B. Just click porosity. The software will ask you how you want to populate the porosity all over the model. Now we are going to use normal distribution. Porosity or uniform distribution, because uniform distribution will ask you about just minimum and maximum. Don't go for complexity issue, which is a standard deviation and mean or whatever. All of this we'll discuss later on, don't worry. For the minimum value, I put 0.1 as a fraction and 0.3 as a maximum. Then apply and OK. If you go for properties, you will see the porosity already populated here. Just uncheck all of these zones as well as skeleton. Okay, just right click on the setting and see what is inside. Already populated the porosity with minimum 10% to 30%. If you go for histogram, you will see it is near to each other very equally, because if you remember we used minimum and maximum, not a normal distribution like before. Anyway, we will discuss further later on. Then apply and OK. If you want to see the variation by color, just go for color as usual and limit by 0.3 as a maximum and 0.1 as minimum value. You see the variation of color by porosity values. We can do the same for water saturation as well as permeability. Let's go for water saturation. Choose water, W, just click on W. Yes, water saturation. Of course, it's not a constant value. We in reality, the water saturation is a function of height, or created from core analysis or from open hole logs. We will discuss this one later on. Okay, for a while I need to do something more advanced. You can consider this as a constant value and consider water saturation as 1. Apply OK. If you click here, of course you have one color because it's very homogeneous property, which is 1 minimum maximum, but we need to do some sort of petrophysics by calculation. Okay, let's go for edit existing water saturation property and use height, cell height, because in this model we have a very high variation in height among the cells. and it's not okay. Okay, apply and okay. Still one. Okay, let's go for a new property, which is yes, we use cell height, and this property as cell height. This is a new property called cell height. Then apply okay. This property differentiates the height function from 0 to the maximum value at the top of the structure. Of course, for the minimum is 10 to maximum 68. Let's consider it 70. Okay, and click OK. Let's create a new property, which is water saturation. Let's say modified by calculator, water saturation, and called water saturation final, or water saturation 1 equal cell 1 over cell height times 10, and see what is the result. We use the same template, which is water saturation, then click enter. A new property tab already open. Just right click to see what is the property already populated here. The minimum, which is 0.14 to maximum 0.99, which is 100. Let's say 100%, supposed to be the bottom of the reservoir, which is more realistic, and we can consider this water saturation, which is minimum, is 0.14. Let's say connect water saturation, and assign minimum and maximum value. 0.1 as maximum, minimum, sorry, and we can leave 1 as a maximum value. Yes, apply and okay. Sorry, 0.17. Okay, if you notice here, because we choose the 5 subdivisions, subzones, you see the difference in thickness is not constant. Okay, for the last property, which is permeability, we assume we have only one permeability, but in reality you have 3 permeability: X, Y, and vertical permeability, which is in Z direction. As usual, we can go for geometry and use permeability. Just click P until reach to permeability function. For a while we use it as a constant value, which is 0. We modify it later on. Right click here, calculator, and assign the permeability value, which is function of porosity. Let's say porosity times 1500. It is very simple approach we can use. We can change it later on, don't worry, and click OK. Just go for permeability, right click, setting. The difference in permeability between minimum 150 to 450 millidarcy. As usual, we can assign the limit, maximum and minimum value in terms of color gradient, 150, and apply. Okay, now you have this model ready with filled with populated properties like porosity, permeability, water saturation, and so we can use more properties later on, and we can modify this model to be more realistic with using the best or common formula in the oil industry. If you watch us in the first time, please subscribe to our channel, and if you have any questions, just drop me a comment. Please don't forget to join our WhatsApp group for more cooperation. Thank you for watching and have a nice day.